In this video, we are going to study ARIMA models identification with correlograms in R. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into RStudio. So the first step within the video is that we need to load the corresponding packages. Therefore, we comment this as step 1, which is packages. And for loading packages, we use a library function and within it the name of the package. So for this video, we'll be using forecast for time series characteristics. And then also with library function, we'll be using ggplot2 for the corresponding charts. To run these code lines, we go ahead, select them, and then we can either click run or we can press Ctrl Enter on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named mData, that's model data, which is equal to the air passengers object. This air passengers object is part of our datasets package, which is already included within our installation. And we want to go ahead and visualize part of this data. So we'll be using head function and within it we include mData object. So to run these code lines, we go ahead, select them, and then we're going to press Ctrl Enter on the keyboard. And as we can see, this creates the mData object within the global environment as a time series of length of 144 observations. And within the console, we can see part of this data being printed, specifically data from January to June of 1949. And this is monthly airline passenger numbers in thousands. If you want to read the full documentation of this data, you can go into the Help tab and search for the object name, which is air passengers. Select it, and then you can see the documentation below. As mentioned previously, monthly airline passenger numbers in thousands from 1949 to 1960. So now we're going to continue with ranges, the limiting. And we're going to create two ranges, a training range for model fitting and a testing range for model forecasting. So we begin with the training range. So we create the object name tData, which is equal to, and here we're using window function and within it the parameters x, which is equal to mData, comma, end equals to c 1958, comma 12. So the training range is going to be the first 10 years of data from 1949 to 1958. That's why we see the end at month 12 of 1958. And then we have fData, that's the testing range. So here we'll be using window function again, and within it we have x equals to mData. But in this case, start equals to c 1959, comma 1. So the testing range is going to be the last 2 years of data, 1959 and 1960. That's why we see the start at month 1 of 1959. In this video, we'll only be working within the training range. So to run these code lines, we go ahead, select them, and we press Ctrl Enter on the keyboard. And then we want to visualize the training range data within its corresponding chart. So here we'll be using autoplot function and within it the parameter object, which is equal to tData or training range data. And we're going to add with LABS, which are labels. Y, that's the vertical axis label. That's going to be air passengers. Then we have X, that's the horizontal axis label, and that's going to be year. So to run this code line, as it is a single code line, we select any part of it and we press Ctrl Enter on the keyboard. And with this, we can visualize the chart within the plots tab. So we zoom into it. And here we have air passengers on the vertical axis, year on the horizontal one, and then we have the solid black line, which is the training range data. So now that we have the data ready, we can continue with step number 3, which is ARIMA models identification. And for this, we are going to study correlograms. And we're going to study two correlograms, the autocorrelation function correlogram and the partial autocorrelation function correlogram. So let's begin with the autocorrelation function correlogram. So we'll be using ggacf function and within it the following parameters, which are x equals to t data or training range data, comma, ci equals to 0.95, that's the confidence intervals, statistical confidence level, comma, lag dot max equals to 24. That's the maximum lag to calculate the autocorrelation function. And then we want to do the partial autocorrelation function correlogram. So again, we have GG, but in this case it's PACF, and within it we include X equals to T data or training range data, comma, CI equals to 0.95. That is the confidence interval statistical confidence level. Lag dot max equals to 24. That's the maximum lag to calculate the partial autocorrelation function. If you have any questions regarding these functions, again, you can go into the Help tab and search for the function name, or you can input within the console $GG and, for example, ACF for autocorrelation function without any parentheses, and you press the Enter key. And as you'll see, that opens the documentation right here within the Help tab. Also, notice that we need to check whether level or d-order differentiated training range time series is needed for ARIMA model integration d-order. Also, notice that ranges delimiting and Correlograms functions parameters were only included as educational examples, which can be modified according to your needs. So let's go ahead and visualize the correlograms. So we'll begin with the autocorrelation function 1. So we select its code line and we press Ctrl Enter on the keyboard. And with this, we can visualize it within the chart. So we zoom into it. And here we have the autocorrelation function correlogram. On the vertical axis, we can see the autocorrelation function. On the horizontal one, we can see the lag. Then we have the black bars, which are the autocorrelation function values, and the dash blue lines, which is the confidence interval. And then we want to visualize the partial autocorrelation function correlogram. So we go ahead and select its code line and we press Ctrl Enter on the keyboard. And right here we have the chart within the plots tab, so we zoom into it. And here we have the partial autocorrelation function correlogram. On the vertical axis we have partial autocorrelation function. On the horizontal one we have lag. Then we can see the black bars with the partial autocorrelation function values and the dash blue lines with the confidence interval. So with this autocorrelation and partial autocorrelation functions, correlograms, we can do ARIMA models identification. If the autocorrelation function tails off gradually and the partial autocorrelation function drops after p statistically significant lags, then we can see the need for an autoregressive model of order p. On the other hand, if the autocorrelation function drops after q statistically significant lags and the partial autocorrelation function tails off gradually, we can see the need for a moving average model of order q. And on the other hand, if the autocorrelation function tails off gradually after q statistically significant lags and the partial autocorrelation function tails off gradually after p statistically significant lags, then we can see the need for an autoregressive moving average model of orders p and q. Okay, so with this we finish with the code file, so we can go ahead and save it. And with this, we also finish with this video. Thank you for watching.